Hello everyone, welcome to Chem 9 lab session. This week we are going to conduct another titration experiment, and in this experiment we are going to determine the concentration of an unknown acid. This experiment is quite similar to the one which we did last week. Remember, in last week's lab experiment we also determined the concentration of unknown acid with the help of a titration experiment, and this week's experiment is also exactly similar to it. A video about how to perform a titration is shown here, so I would highly recommend all of you to watch this video before submitting and completing the lab report. As usual, the experimental instructions and other instructions about calculations are given in this PDF file here. So let's take a look at the experimental procedure. In this week's experiment, we are going to determine the concentration of an acid with the help of a titration experiment. The acid which we are going to use today is acetic acid, and this acid is present in vinegar. So objective of today's experiment is to determine the molarity of vinegar solution. The commercially available vinegar solution is not pure acetic acid. It is actually a diluted acetic acid, and we will conduct this titration experiment to find out the concentration of acetic acid in that vinegar solution. So we will calculate the percentage by mass of acetic acid in vinegar solution, and we will compare our finding with the concentration reported on the bottle. We already learned how to conduct a titration experiment last week. I will briefly go over the experimental procedure one more time. So titration experiment is essentially an acid-base neutralization reaction. So today we are going to use acetic acid. So formula of acetic acid is an acetic acid reacts with a base, and we are going to use sodium hydroxide as a base today. And as usual, acid and base, they neutralize each other, and the product of this neutralization reaction is water and a salt. In this case, the salt will be sodium acetate. The reaction equation is also given in the instruction PDF file, and this equation is already balanced, and you will notice that for every 1 mole of acid we need 1 mole of base to completely neutralize each other. So therefore this reaction is what we call 1:1 reaction. So we can write from this balance equation, we can write a conversion factor. So 1 mole of acetic acid, I'm just gonna simply write acid, is equals to 1 mole base, and base is NaOH. So this is the equation. Now how are we going to conduct the experiment? And in this case, so we are going to take our base in a container is, and the name of this container is butyrate. This butyrate has a scale on the side, and normally the volume which can be taken in butyrate is 50 ml. So the scale will read 0 ml on top and 50 over here. So when we fill this butyrate all the way up to top, that means we have 50 ml of any solution in the butyrate, and there is a valve down here, and the solution can be taken out of butyrate by opening this valve. So in this experiment we are going to take our base in the butyrate. Our base is sodium hydroxide, and we are going to take acid in an Erlenmeyer flask. We are going to take a specific quantity of acid, and in order to perform the titration experiment, titration essentially means neutralization of acid with a base. Now for sodium hydroxide, molarity is known. And for acid, molarity is unknown. So we will take some constant volume of acid. So volume of acid which we are going to take in today's experiment is is 5 milliliter. So in titration experiment, what we are going to do is we are going to neutralize this acid with the help of this base. So the way we are going to conduct this experiment is we are going to open this valve, and then we are going to dropwise add base to it. As soon as the base is added to the acid, the base will start neutralizing it. In the beginning, only a small quantity of acid will be neutralized, but as we keep adding more and more base, of course dropwise addition will be carried out, and it will continue to neutralize, and eventually at certain point we will add enough base so that acid is completely neutralized. So at that point we need to stop this experiment. So maybe imagine we added 12.5 ml. So we started with 0, so this much was added to completely neutralize the acid. So our starting value of base was 0 ml, and end value and end volume of base, so end volume is when the acid was completely neutralized, was 12.5. So total amount of base added was the difference between these two values. So total volume of base added was 12.5 minus 0, and it will come out to be 12.5 ml. Now how do we know that the acid is completely neutralized? To determine that, we add an indicator. So indicator is a solution whose job is to indicate when the acid has been completely neutralized. In this experiment we are going to add phenolphthalein as indicator. So what this solution does is it will change the color from colorless to pink at the end point. Now end point is the point where acid is completely neutralized. So in other words, once the acid is totally neutralized, the solution will become pink. So at that time we are going to stop the addition of NaOH, and we need to just note down the volume added, and that will be the end of experiment. Rest is calculation. So let's go back to the experimental section. So the calculations are given in the lab report, and as usual lab report can be found in the last tab. So let's open the lab report. So in lab report we are going to request provisional data. So here you need to select yes, that we are completing experiment online, click next, and then request provisional data and confirm. So this data is already given. So what this data is telling you is the starting volume of base in the burette. It is also telling you the molarity of the base which was in the burette, and it is telling you the volume of acid which was taken in the flask, and it is telling you how much base was added to completely neutralize the acid. Okay, so the starting value in the burette was 1.25 and the end value is 48.25. The difference of these two numbers, 1.25 and 48.28, will give us the total amount of base added to neutralize the acid. Molarity of base is already given to us, and the volume of acid is also given to us. Okay, from these values we can calculate the molarity of unknown, molarity of this vinegar solution. And the experiment was repeated 3 times. So trial 1 is the first attempt, trial 2 is the second, and trial 3 is the third attempt. Okay, so same data is given in the table 2. Okay, so expected color at the endpoint. So we already know that endpoint is the appearance of pink color. So faint pink, you can select faint pink. So because as soon as pink color appears, that's the endpoint. So we do not want to continue to add base even after the endpoint. So if you add extra base even after the neutralization has been achieved, then this pink color will become dark and eventually it will become purple. So having a dark pink or purple color means that your experiment did not go that well. So it means you have unnecessarily added extra amount of base to neutralize the acid. So the faint pink is the best color, or that should be the expected endpoint. So select faint pink. Now volume of NaOH used is calculated by subtracting the final, subtracting the initial burette reading from the final. So in trial 1, so this value can be calculated by subtracting 1.25 from 48.28. So this subtraction will give us the total volume of NaOH used to neutralize the acid. Similarly, calculate the total volume of NaOH used in the other 2 trials and calculate the volume average. So the average volume is the sum of these 3 numbers and divided by 3. So that will be the average. Imagine that this answer comes out to be V1 and this is V2 and this number is V3. Then the average is, make sure you use parentheses, so V1 plus V2 plus V3, whatever those numbers are, add them up, use parentheses, and then divided by 3. So this formula will give you the average. Next is average moles of NaOH used. So the moles of NaOH used is equal to the volume multiplied by molarity. So it's calculated by molarity multiplied by volume. So molarity of NaOH, of course, multiplied by volume of NaOH. Volume of NaOH was just calculated here, so that's the average volume of NaOH here. So use this average volume, and molarity of NaOH is given to us in the initial data table. So this is the molarity of NaOH, 0.100. So use these two values to calculate the average moles of NaOH. Next is average moles of acetic acid. Now average moles of acetic acid come from the balance equation. So as we saw in the balance equation, that for every 1 mole of NaOH we need 1 mole of acid to neutralize it. So our equation is 1 mole of acid equals 1 mole of NaOH. So therefore, using that concept, whatever value you get here, average moles of NaOH, same value will be here. So this will be same as average moles of NaOH. So whatever value you get here, same value will go here. Next is average molarity of acetic acid. So molarity of acetic acid is calculated by moles divided by volume. Remember, molarity is equals to moles divided by volume, but this volume must be in liters. So if we are calculating molarity of acid, so then it would be moles of acid divided by volume of acid in liter. Okay, so we already know what are the moles of acid. So moles of acid are already here, right? And the volume of acid is also given. So volume of vinegar sample, so that's our acid, that's 5 ml. But here we need to convert 5 ml to liters first. Okay, so imagine that this number comes out to be maybe it is A. So our average molarity will be this value A divided by 5 ml into liters. When we convert 5 ml to liters, we will get 0.005. So this should be the average molarity of acid. Now average mass of acetic acid, the calculation is given here in the instructions. So so that's the average molarity of acetic acid. That's the formula we already used. So this is the formula to calculate the mass of acetic acid. So mass of acetic acid is equals to moles of acetic acid multiplied by 60 divided by 1. So we can ignore 1. So in the calculation table, so average mass of acetic acid is equals to moles. So moles are A. So A multiplied by the molar mass. So molar mass is 60.1. So 60.1 grams. Okay, so so these many grams will be your average mass of acetic acid. Next is average mass of vinegar in grams. Assume the density of vinegar is 1.00 grams per ml. So this is the formula to calculate the mass of vinegar. So this mass of vinegar is equals to volume of vinegar multiplied by density of vinegar. Now density of vinegar is 1, so therefore mass of vinegar will be same as volume of vinegar. And in this experiment we took 5 ml, so therefore the mass will be same as 5, so it will come out to be 5.00 grams. And finally, average mass percent of acetic acid in vinegar. So mass percent of acetic acid in vinegar is given in this formula. So mass percent is equals to mass of acetic acid divided by mass of vinegar multiplied by 100. So mass of acetic acid is this number, and the mass of vinegar is this number, 5.00. So divide this number by 5.00 multiplied by 100. So that will be your average mass percent of acetic acid in vinegar. On the bottle, the manufacturer claims that the percentage of acetic acid in vinegar is 5.45. So hopefully our number will also be similar to 5.45. And finally, we need to calculate the percent error. Percent error can be calculated using the formula given here. So percent error is equal to given mass percent minus calculated mass percent divided by given mass percent multiplied by 100. So in this experiment, the given mass percent of acetic acid in vinegar is 5.45. So it is given to us, and calculated value is the one which we will calculate. Imagine that we end up calculating 5.3. Your number may vary. I'm just taking a random guess value. So imagine that we obtain this value as our answer. So the mass percent calculated by our calculation is 5.3, and the mass percent given to us is 5.45. Using these two numbers, we can calculate the percent error. So let's plug in those values. So percent error will be equal to, so given is 5.45 minus calculated was 5.3 divided by 5.45 multiplied by 100. So the meaning of these lines is that we are going to use the absolute value. It means even if your answer comes out to be negative, you will ignore the negative value, just take the absolute value. So this in this case we will get 0.15 divided by 5.45 multiplied by 100, and if you calculate it this calculation, then we will obtain percent error to be 2.75%. So please use your own value of calculated mass percent to calculate your own percent error value. And this will be the end of the lab report. There are some post-lab questions here, and these post-lab questions are based on the calculations which we just discussed. So use those calculations as reference and answer all those questions. If you have any question, please contact me by email or see me during my office hours. Have a wonderful rest of the day. Bye-bye.